Today's video is going to be revision of solving simultaneous equations. I'm going to do two examples of simpler simultaneous equations and then an example of a more difficult simultaneous equation. So the first example I'm going to do is if we have the simultaneous equations x plus y equals 11 and x minus 3y equals 7. Now this is quite a simple equation to do because we've got the same two variables in each, which we should always have, but also we've got the same multiple of one of the variables. In this equation we've got one lot of x, and in this equation we've got one lot of x. Because of those variables matching, the easiest thing to do is to just subtract this equation from the first one. So we'd have x minus x gives us 0. Y minus negative 3y gives us plus 3y. And 11 minus 7 gives us 4. Oh, sorry, that should be y plus 3y. So that would be 4y. So then we would have y equals 1. And then we can plug that back into one of the equations. I'm going to choose this one. So that gives us x plus 1 equals 11. So x must equal 10. So we've got y equals 1 and x equals 10. Let's check that in this equation. So 10. So this is our check. 10 minus 3y, so minus 3, equals 7. And that is correct. Next example, solve the simultaneous equations 5x minus 4y equals 23 and 2x plus 6y equals negative 25. This is different from the last set of equations because we have the same two variables, but in each equation they have different coefficients. So 5 and 2 don't match, negative 4 and 6 don't match. What we want to do is we want to multiply these equations so that we've got a matching multiple, and we usually go for the lowest common multiple of two of the coefficients. So we could go for the lowest common multiple of 5 and 2, or we could go for the lowest common multiple of 4 and 6. The lowest common multiple of 4 and 6 is 12. So I'm going to multiply this one by 3, and I'm going to multiply this one by 2. So that turns them into 15x minus 12y equals 69, and 4x plus 12y equals negative 50. This coefficient and this coefficient match, except the signs are opposite, which means I'm going to want to add the two equations together, and that will cancel these 12y's out. So if I do that, I'm going to have 19x, negative 12y plus 12y, so plus 0, equals 69 plus negative 50, which gives us 19. So this time x equals 1. I can then plug that into one of the equations. So I'm going to put it into this top one. So 5 minus 4y equals 23. That means negative 4y equals 18. Which means that y equals negative 18 over 4, which is negative 4.5. And if we check that in here, we should have 2x, so that's 2. 6 times this will be negative 27, so minus 27, and that does equal negative 25. In the last two examples, the variables have been kept separate. This one is a trickier example now. So we've got x plus y equals 5 and 2x squared plus xy equals 14. So if we want to solve this set of simultaneous equations, we can't just multiply to get the same coefficient. Well, we actually could. We could multiply this top one by x, and we'd have x squared here and xy here. So we could do that. But the other thing that we could do in the method that you're more likely to use is rearranging one of the equations and substituting it into the other equation. So here we've got x plus y equals 5, which means that y equals 5 minus x. We're then going to substitute that y into here. So that's going to turn into 5 minus x. So this equation will be 2x squared plus x into 5 minus x equals 14. We'll then multiply that out. So we've got 2x squared plus 5x minus x squared equals 14. Which means that x squared plus 5x, and then I'm going to bring 14 onto this side by subtracting from both sides because I've now formed a quadratic. And then say that that's x minus 7, no, plus 7, sorry, x minus 2 equals 0. So our solutions for x are x equals negative 7 and x equals 2. That means we need two solutions for y. When x equals negative 7 plus 12 would give us 5. And when x equals 2, 2 plus 3 would give us 5. So that is how we would solve that equation. Going back to what I said at the beginning, we could multiply these to make the coefficients the same. This won't always be an option. Sometimes it will be too difficult to identify what you need to multiply. But I'm just going to run you through multiplying this one instead. So we could change this equation by multiplying through by x, so that we get x squared plus xy equals 5x. We could then subtract this one from this one. So I'll write it again underneath. X squared plus xy equals 5x. If we then subtract, we'd have 2x squared minus x squared, so that's x squared. Xy minus xy, so that's plus 0. 14 minus 5x. Then rearrange it to get a quadratic. We'd have x squared plus 5x minus 14, and again factorizes into x plus 7, x minus 2. So we get the same solutions, x equals negative 7 or x equals 2, and their corresponding values would be y equals 12, y equals 3. Okay, that should be enough for you to have a go at the examples I've put up. If you get stuck, as always, please let me know.